and today I want to talk to you about migrating from CloudFormation to the CDK. So if you haven't heard about the CDK before, it's an open source infrastructure as code framework that allows you to write high-level code in familiar programming languages. We support JavaScript and TypeScript, Python, Java, and C# currently. And the code gets executed and as a result produces one or more CloudFormation templates which actually provision your infrastructure. So the CDK uses CloudFormation as its deployment engine. And because of that, a natural question is, I'm already using CloudFormation in my applications to manage many different stacks. How can I migrate them to be now managed by the CDK? So in this video, I want to show you a real-life demo of how we would go from a stack managed purely in CloudFormation to one that is managed using the CDK. So here I'm logged into my test account through the AWS console, and let's go to the serverless application repository and let's deploy one of the applications that are available for it. Let's use the API Lambda Safe DynamoDB application. So to deploy it, we just have to fill one parameter, which is the name of the DynamoDB table. Let's just call it safe table, and let's deploy this application into my AWS account. So the deployment has started. We can go to the CloudFormation AWS console and we should see the stack. Yep, so here is the stack. It's being created and it should finish deployment momentarily. Great, so the stack has deployed. You now go to it. We can see that it has 7 resources inside of it. And we can test it now. So if we go to the Outputs tab, we can see that one of the CloudFormation outputs is the URL of the API, and we can copy it. And once we do, we can send an HTTP request using the options verb. So I'll be using curl for this, and the option is -x, and then the URL. And I will use the -i flag to curl so that we see some details from the response. So we see that we get a 200 response from our application and a bunch of headers related to cross-origin request policies, as this application supports CORS, and an empty body. So that's great. So let's now migrate this stack that we just deployed to use the CDK. How will we do it? Well, let's start with creating a brand new CDK application, and for that I will use the CDK CLI. So I will use the init command, which allows you to create the skeleton of a new CDK application. I will pass it the option to use TypeScript as the language. Of course, you can use any language supported in the CDK, and it will work very similarly to what I'm showing now. I'm just using TypeScript because it's the most popular. Great, so a new application has been created. Let me now open it in my editor. I'm using IntelliJ, but of course you can use any editor that you like. You can use Visual Studio Code, you can use Atom, you can use Sublime Text, WebStorm, Visual Studio, whichever editor suits you for writing your runtime code. You can use that same editor for your infrastructure code with the CDK. So this is the correct directory. Let me open this project. I will just accept all of the defaults. So this is a standard skeleton application that the CDK init command generates. For TypeScript, as we can see, we have the package.json file that contains all of the dependencies that we need. We have the entry point file that defines one stack, which is defined in a separate file. So how do we now use this newly created CDK application to migrate that stack from the serverless application repository that we just deployed? Well, the first step is adding a dependency on the AWS CDK CloudFormation include module, which is a module that's specifically designed to help with migration from CloudFormation to the CDK. So we need to add it as a dependency. It's available as a different module in all of the CDK supported languages. So there's a Java module in the respective package managers with a very similar name that contains the same functionality, just in a different language. Great. So the package has been installed, and now we can use it in our stack. Let's first import it. In our stack code, and then the CloudFormation include module contains a single construct that we instantiate as all construct, passing 3 arguments. The first one is the scope, which is usually this, and it's the same in our case. Then the second one is the logical ID, which for this one we can call the template. And then the third argument are the properties, and in this case we have a single required property, which is the path to the file containing the contents of the template that we want to migrate. So to obtain that file, we can go back to the AWS console for CloudFormation, and in our stack we have the template tab, and it contains the actual contents of the deployed template, either in JSON or YAML format, and the CloudFormation include module supports both. Now, an important point is that if you have a template that uses a transform, the most likely one is the serverless transform, make sure that the view process template is unmarked actually here. So this is the incorrect version and this is the correct version. So that's because the including process will not execute any transforms. So you need to download the unprocessed template from CloudFormation. So I can just copy this, and if I go back to my IDE, I can now create a new file, and the path in the project and the name of this file is pretty much irrelevant. It just has to be the same as the name you use in the code. So I will just call it sartemplate.yaml because this template uses a YAML file. And this is the important part. This file needs to be stored in version control alongside the rest of your CDK code. So I will add it to Git here. But note that this is a one-time operation. So after you perform the migration, you will not have to worry about this file anymore. All of the changes to your application will go through CDK code. So this template will remain as it is, and you will not have to edit it manually again. Okay, so we have the file saved locally, and now we can create the CFN include construct, passing it the path of that file that we just created. So in my case, because I saved it in the root of the project, it's just sartemplate.yaml. And now if we execute the CDK diff command, which shows the difference between what is defined locally in your CDK code and what is defined in your stack, it should show how the migration is going. But before we do that, I forgot one important part. We have to make sure that the name of the stack is exactly the same name as the deployed stack. So you see here, that's not the case right now. So I need to go back to the AWS console for CloudFormation, copy the name of the stack, and make sure that my CDK code uses that same name. And now if I execute the diff command, we see that there is a single difference between my locally defined CDK code and the actual deployed stack, and that is that the locally defined code contains this CDK metadata resource. So that is a custom resource that the CDK adds by default to every stack it manages, and it records which modules you use to define that stack. And that is a tool that is helpful for the CDK team because it allows us to better prioritize work. So knowing how popular each of the modules are, it actually helps us to know which modules are the ones we should be investing our time in. So this is absolutely normal, but notice that other than that CDK metadata resource difference, all of the rest of the resources are exactly the same. So all of that 7 resources that we saw before are completely unchanged, and the CDK diff doesn't show any difference between them. So now, if we run the deploy command, what should happen is the metadata resource should be added and the application should still be working after the deployment. Great, so the deployment succeeded. So now if you go to the AWS console for CloudFormation again, we go to the resources tab, and if we refresh it, we see now that there are 8 resources where there were previously 7 of them. So we see the CDK metadata resource added here. And if we go to the outputs tab again and copy the URL, we can test that the application still works exactly as we did before. So we send the options HTTP request for the URL, and we see it still returns 200, a bunch of CORS rated headers, and an empty body. Great. So at this point, you have successfully, and if we run CDK diff again, this time we should see no differences between our local code and the stack that was deployed. Great. So at this point, you have migrated from CloudFormation to the CDK. So that's great. But we haven't really done anything interesting, and usually when you want to migrate an application, you actually want to make some changes to it. So how can we do that using CFN include? So if we look at the API of this class, we will see that it has a bunch of methods that allow you to take out various elements of the template. So of course you can get our resources, but also conditions, mappings, outputs, parameters, etc. So if we look at the template, we see it has a few resources defined here. And the most interesting one is probably the Lambda function with the logical ID Lambda saver. So when taking out elements from the template, you provide the logical ID, so Lambda saver in this case. And if we look at the type that getResource returns, we see it's CFN resource, which is the common superclass for all CloudFormation resources in the CDK. However, if we know what CloudFormation type a given resource has, we can actually cast the returned object from getResource into its correct CDK type. So we see that Lambda saver is a AWS serverless function, and I happen to know that the serverless CloudFormation type corresponds to the SAM module in the CDK. So I can add it now to our imports. There you go. And now I can cast the object returned from getResource to the CFN function type. And if I now use my ID's autocomplete, I see that the function object has a bunch of properties that I can now mutate. And any changes I make will be reflected in the resulting template. So for example, I can change the runtime property. So if we look back into the template, we see that the runtime is Node.js12.x. Well, maybe I want to change it to, let's say, Node.js14.x. And if I run the diff command, I should see a single difference between my local CDK code and the deployed stack, and that is that the runtime property has been changed. Okay, so that's great. And in this way, you can take out any resource from your template, and you can mutate any of its properties, and any changes you make will be reflected in the resulting template. And notice that a very interesting thing happened, and that is we went from this unstructured, untyped world of YAML into a well-typed and well-structured world of the programming language that we use. So even though this is a YAML file that is the input, the objects that we get actually conform to the correct CDK types, and we get help from our IDEs and editors exactly as we would if we were defining a new a new CDK application. So we see here that we know that the runtime property is there because of the autocomplete that our IDE provides. We see that the type of runtime is string, so if I try to pass a number here, the compiler will helpfully show me that error, and I can also see the documentation for this type, and I can even click on it to go to look at it in the browser. So that is great, and that is exactly what we expect when writing CDK code, and we get that kind of help when migrating from CloudFormation to the CDK. So that's great, but the runtime property is not that interesting to change in this case. Probably the most interesting property for the Lambda function that we have here is the code URI property, which determines where is the actual runtime code for this function stored. And if we look at the template, we can see that it has a reference to this bucket, which is a special bucket used in the serverless application repository, and it contains a bunch of publicly available files that define the contents of the Lambda that are used. But since this is our application, we want to have control over that code. We don't want to just point to some code in some public bucket somewhere. We want to have that code under our control so we know what it is and we can change it. So the way we do that in the CDK is through something called assets. So assets allow you to reference files on disk, and the CDK will make sure to transfer those files before deployment happens into an S3 bucket, from which then they can be referenced by CloudFormation during deployment. So how do we get the assets for this particular function? Well, we can go back to the AWS console, and if we go to the AWS console for Lambda, we see here our one function that we have deployed, and if we click on it, we can then perform an action called export, which basically means downloading the zip file that contains the contents of our function. So let me save it here. Great. And I can now go to Finder, and I can actually unzip this bundle. So if I go back to my IDE, I see the file here, and you notice inside the directory that I just unzipped is the actual runtime code of my function. So we have the package.json files and the node modules that declare the dependencies, and then we have the index.js and process response files. Okay, so it's great that we have it locally. How do we turn it into a CDK asset? So for that, we first need to import the corresponding CDK library, and since this is CDK asset, sorry, an S3 asset. We need the AWS S3 assets library. And we create an asset like any other construct, so passing 3 arguments, the scope, which is this, the logical ID, which we can call lambda code, and finally the options, or the properties rather, excuse me, for which there is one required property, which is the path. And if we go back, we can actually rename this directory to be a little more readable. Again, it can be anything you want and placed anywhere. I will just place it in the top level root directory of my project, and now I can just call it lambda code inside my code. Let's save it in a local variable. And now what we need to do is we need to change the code URI property of the lambda saver function in our template to point to that asset instead of the publicly available bucket as it is now. So what do? We mutate the code URI property, and we get the bucket, the bucket property to be lambda code S3 bucket name, and then the key to be lambda code S3 object key. Nice. So if we run the diff command again, we see that there have been a bunch of CloudFormation parameters added to the template which represent our assets, and the code URI property has been changed to reference those parameters instead of the hard-coded public bucket as was before. So if I deploy this, the code of the Lambda should be updated with the local contents that I have on disk, and the applications should still respond as it did before to the options HTTP request on the save path. Great, so the deployment succeeded. Let's see if responds to curl, and it does. Great, so we still get a 200 back, a bunch of headers, and an empty body. So that's nice, but now that we have the Lambda code kind of in our possession here, we can actually change it. So one of the things that I don't really like about this application is that it actually doesn't respond to GET requests. So if we remove the -x options flag from curl and we try to send a request like this, you see we'll get a 403 HTTP response and a generic missing authentication token error back from API gateway. And the reason for that is that this application doesn't define a route for the GET method. It only defines one for post, and options because it supports CORS. Now I don't really like that. I feel like especially these kind of example applications from the serverless application repository should almost always respond to GET requests. It's just an easy way to test whether the application has been deployed correctly in the browser, and it's just much more convenient than sending, options request. Okay, so let's change that. So if we look at the template, we see that the Lambda function has these events property, and right now it defines only a single event, which is the post event. So we need to add a new event here that responds to GET. So we go back to our CDK code, and the way we can define this event is, let's call it just a greet event. And to get some help from our IDE, we'll tell that the type we want is the CFN function event source property. And we have to fill the properties property in this case. So it has a few things that we have to fill. So the method, in our case it's now get, we need to fill the path, which we want to be the same, so save. And finally, the REST API ID. Excuse me. So if we look at the template, this is a reference using the CloudFormation ref intrinsic to the save API resource, which is defined here. So how you can do that in the CDK? Well, we take out the save API resource exactly as we did before. And we can then create a ref intrinsic function to it using the ref property. So that handles the properties property, and the last one is the type property, which has to be API, exactly as the event for post. So great, we have the greet event, but now we have to add it to the events map. So if we look at the events property, its type is actually a little complex, but we don't have to worry about that because we know it's a map. So let's just silence kind of the compiler here, and let's just say it has an any type because we know what we're doing in this case. So we can just modify the events map and just add a new entry under the key greet API to our newly created greet event. So great, that adds a new event to the Lambda property, but now we have to actually modify the code of the Lambda to correctly handle that get event. So if we open the index.js file, which has the handler that is the entry point, it does a bunch of things. I don't want to get too much into the details of what exactly they do, but we see here that it checks the HTTP method that it gets and does something special for options. So we can add a similar if that handles get. So we say that if the HTTP method is get, we return this process response function. And the second argument to that function is the body. So we can say something like, hello YouTube audience, to make sure that what we get in response is exactly what we changed in the Lambda. So now that we have these changes in place, we can test the application by sending, first of all, running the diff command. You see, we get a nice error saying that we probably used, yes, I used the wrong casing here. Great, we got a very nice error message saying that a resource with save API with capital P was not found in template, of course, because it needs to be a lowercase p. Let us run CDK diff again. And we see a bunch of changes. We see that the values of the asset parameters change because we actually changed the contents of the Lambda code. And we see that the events property changed. We added a greet API entry to it. So now that we can now deploy these changes to our running CloudFormation stack. Great, so we get a printed output that contains the URL. So if we send now an HTTP GET request, which is the default if you don't provide the -x flag to curl, to that same URL that we used before for the options HTTP request, we should get a 200 and the hello YouTube audience greeting that we put in our Lambda's code. And that's exactly what happened. So we get a 200 back and we get the body in response exactly as we hoped. So I hope this has been useful. So it only took us about 20 to 30 minutes, and we were able to take an actually deployed CloudFormation stack that was running in our account, and we were able to migrate it to the CDK without incurring any downtime, without having to create a new stack and have both of them running concurrently, which makes things complicated. We just took the running infrastructure in the CloudFormation stack and we made it completely managed through the CDK, and we were able to leverage all of the benefits of the CDK, like your editor's autocomplete, the type safety of the programming language that you're using, the inline documentation, exactly as we would leverage those advantages if we were writing a brand new CDK application. So I hope this was useful. If you have any feedback on the CloudFormation include module in any language, please create an issue in our GitHub repository. And happy hacking on the CDK, and I hope you migrate all of your CloudFormation stacks to use the CDK, and it will be very easy and painless. Thanks so much for watching.